Okay, good evening everyone. Good evening. Good evening Sadguri. Good evening Shafia. Good evening everyone. Good evening. Okay, what about others? Good evening all. Good evening. Good evening everybody. Okay, so friends, let's start. In the last class we were started discussing about the enzymes. Good evening everyone. We were started studying about the enzymes involved in the process of DNA replication. Good evening all. Please join, please continue. Okay, good evening all of you. So friends, let's continue. So we will discuss up to 15 minutes, then I will give the time, then you can ask all your doubts like as usual. Okay, now friends, if you quickly recall, in the last class we have discussed about the enzyme helicase also friends. Even we have discussed about the enzyme SSB also. So now let's talk about the another type of enzyme and very important enzyme. What is this particular enzyme called as? Good evening all, please continue. We called topoisomerase enzyme. Friends, this particular topoisomerase enzyme, we will be also calling it as what friends? Gyrase enzyme. Now I have told you very clearly one important point. What is that? The helicase enzyme move very faster, is it? So friends, we discussed that the enzyme helicase will move 1000 base pair per second. So in one single second it's keep on opening 1000 base pairs. So what is this point you people has to remember here? Since helicase is moving very faster, it may create a tension, it may create a pressure on the DNA. So friends, because of that particular pressure, the DNA undergo the process of coiling. So to remove that particular coiling, there is an involvement of an important enzyme which we call it as friends topoisomerase enzyme or gyrase enzyme. Good evening all. So friends, what we people has to remember here, actually in this particular thing, we have to remember what are the type of topoisomerases are present and how one topoisomerase enzyme is different from the another topoisomerase enzyme. In this particular slide I am explaining, listen my statements once again carefully all of you. In this particular slide I am just explaining you the overview of type of topoisomerase enzyme. When we are reading the original process, I will explain you how exactly topoisomerases will cut the single strands as well as the double strands also. Good evening all of you, please continue. So as I am saying friends, there are two type of topoisomerases are there. Topoisomerase 1A, topoisomerase 1B. Good evening all. So and at the same time topoisomerase 2 also having two subtypes. We can call topoisomerase 2A and 2B. My friends, what are the major statements I want you people to remember for the exam point of view is that topoisomerase 1A and 1B, always keep it in your mind, they will only cut the single strand. First unique statement all of you has to remember for the exam. And topoisomerase 2A and 2B, my friends, they are basically involved in cleaving the double stranded DNA. Please kindly don't forget that point at all. So friends, once again all of you listen to me very carefully. Topoisomerase either 1A or 1B. Suppose example, if the topoisomerase 1A wants to work, it requires some metal. So most of the time they will use the magnesium or zinc as their metal. So here the metal function is what friends? The metals are acting like a cofactors. Friends, when you look into the 1B, it did not require any kind of a metal. Even though metal was absent, it will work with the highest accuracy. And what is the unique statement, friends? The topoisomerase 1A and 1B, they are actually not at all dependent on the ATP. But what is the unique statement? All of you has to remember, they do not having the ability or capability, friends, to cut the double stranded DNA. Instead, they are only cleaving the single stranded DNA only. I want you people to remember this point without fail. Now friends, when you look into the topoisomerase 2A and 2B, all of you pay attention, friends. 2A and 2B, they compulsory require any kind of a metal as their cofactor. As I told you, mostly they can use either magnesium or copper as their cofactor. I'm so sorry, it's not copper. Magnesium or zinc as their major cofactor. And what is the unique statement? Once again, you all people has to remember, the topoisomerase either 2A or 2B, my friends, they are going to cleave only the double stranded DNA. And moreover, friends, in order to cleave the double stranded DNA, friends, the topoisomerases compulsory require the ATP. Without ATP, friends, topoisomerase 2 cannot show any action. So friends, I want you people to remember these 3 points without fail. Once I am teaching the process, there I will highlight the specific action of the topoisomerase 1A and 1B with the diagrams, and I'll explain in a crystal clear way. So in this slide, I want you to remember there is 1A, 1B, 2A, 2B. 1A, 1B, which are belongs to the topoisomerase type 1, they are basically going to cleave only single strand. When you look into the topoisomerase 2A, 2B, they are basically going to cut the double strand. Topoisomerase 1A and 1B, they did not require the ATP. Topoisomerase 2A and 2B compulsory require the ATP. Do not forget that point, friends. Right now, what we are studying is what are the enzyme, what is their majority of functions. Primase, friends, in case of a prokaryotic organism, I want all of you has to remember, friends, in case of, why I am not audible? I think I am audible to everyone. Lakshmi, I want you to refresh and I want you to look into your internet connection. I feel I am strongly audible to all of you. Please rejoin, you will be audible. Okay, so friends, in case of prokaryotic organism, this particular primase, also called as what, friends? DNAG. Please kindly do not forget this particular point. Whereas, friends, in case of a eukaryotic organism, we will be normally calling it as the primase only. I have already told you very clearly what is the function of a primase, friends. So these two are the DNA. Parent strands are separated and acting as a template strand. Here one primer. Here you remember, in case of a lagging strand, we will be adding the multiple primer. I want every one of you look into the diagram very carefully, friends. In case of a leading strand, you only please kindly look into this. We have added just one primer. But friends, in case of a lagging strand, you only try to understand, friends, we have added multiple primers. Don't forget that. In leading strand, one primer. In lagging strand, multiple primers. And the important points you people has to remember, for exam, the length. What is the length of this particular primer? So the length of primer will be 11 plus or minus 1, where it is in case of a in vivo. In vivo means what, friends? Within the laboratory. Whereas in vitro, I already told you, right? I'm so sorry, friends. I'm extremely sorry. In vivo means in the body. I'm sorry. In case of a in vitro or within the laboratory, it is 60 plus or minus 1. So in vitro, we basically call it as what? Laboratory. I hope you all recalled. If you recall quickly our PCR technique, in our PCR technique, first step is the denaturation. Second step is what, friends? You remember, we will, once we denature this particular two strands of the DNA, immediately we will start adding the primer. is it? So whenever we are adding the primer, all of you listen, we will add the primer up to 16 nucleotide. That is in the in vitro only laboratory. But in our body, if the polymerase enzyme wants to work, it just require 11 plus or minus 1 only. And the unique statement I want all of you has to remember for the exam is this one. That is primase is a kind of a RNA polymerase enzyme. Please kindly do not confuse, friends, and kindly don't think that it's a DNA polymerase enzyme. That is absolutely wrong. It's a type of RNA polymerase. Good evening, Shivani. Continue. Now, friends, now we are going to read about the king of all the enzymes, DNA polymerases. If you forgot other enzymes also, that's okay, but I want you to remember. But I am requesting everyone, pay utmost attention from this particular slide, because we have to read and remember every single enzyme along with its mechanism of action. Most importantly, friends, listen, every student has to remember the structure also. At the same time, friends, every student has to remember what we can say, most important one, functions performed by them. Okay, now listen to me. There are total 3 DNA polymerases are there. So friends, listen to me for the period of 15 minutes. Automatically, after that, I'll solve your doubts. So pay attention. Try to understand every single pinpoint. In case of prokaryotes, there are 3 DNA polymerases are there. DNA pol 1, pol 2, pol 3. In case of eukaryotes, since we are very complicated organism, friends, we will be having total 5 DNA polymerases, alpha, beta, gamma, epsilon, delta. But right now only you all people remember, friends, in case of a prokaryotic organism, we will call DNA polymerase 3 is the important and principal enzyme. Principal enzyme means which is the most important enzyme among all. Friends, when you look into the eukaryotic DNA polymerase enzyme, friends, we will called polymerase delta is the most important or principal enzyme. Anyway, let's understand why we are calling only delta and polymerase 3 are the principal enzymes. Why not any other kind of the polymerases? So let's try to understand in a simple, elaborative way. First, let's talk about the polymerase, 3 polymerases in prokaryotes. Then we will come to the eukaryotes. Friends, before moving on to the 3 polymerases, first let me explain to all of you, friends, the differences. And before saying the differences also, let me tell you one more interesting point. What is that interesting point? You can ask me, sir, any kind of a substance or any kind of an enzyme can act like a DNA polymerase? No. You should not think that any kind of an enzyme can act like a DNA polymerase. No. Friends, if any enzyme want to act like a DNA polymerase, it exactly has to possess 2 important characteristics. Whenever the enzyme possesses these 2 important characteristics, then only it can act like a polymerase enzyme. What are those? The first one, we will be calling it as, friends, polymerization rate. First one, what do you call, my friends? Polymerization rate. And the second most important one, we will be called, my friends, processivity. So friends, because of the polymerization rate and because of the processivity only, we will be calling a particular enzyme as the DNA polymerase enzyme. Good evening all. Okay, I will tell in a very simple and unique way. Just listen. What is polymerization rate and what is processivity? Just listen to me carefully. Here, don't confuse. Here, polymerization rate means how many number of nucleotides can be added per minute. Or how many number of nucleotides it will be added before it's falling off. That is what polymerization rate. Then I can define the processivity just like this. Processivity means, friends, ability or capability of enzyme. Ability or capability of enzyme to do a particular function. In a simple way, how long how long or how much extent the DNA polymerase enzyme continuously adding the nucleotides. That is what do you call processivity. In other words, I will tell you to make you understand easily. See, I am a person, I can walk for 10 kilometers. Listen to me carefully. I am a person, I can walk for 10 kilometers. And second point, I can walk the 10 kilometers without stopping. Without stopping in the middle, I can walk 10 kilometers continuously. So here what is polymerization? That I can walk 10 kilometers. The target is polymerization. Processivity is what? I am running 10 kilometers without stopping. That is processivity. Same way, polymerization rate means how many number of nucleotides it is adding. Processivity means how accurately it is adding, how much extent it will continue the same process. That is called, friends, processivity. Now, when a particular enzyme can possess these two characteristics, then only we can call that particular enzyme as a true DNA polymerase enzyme. As I told to all of you friends, there are three polymerases are there. First, let me tell you simple differences, and later we will cover every single point individually about the polymerase. Once again, I am remembering to all of you, the PPT itself will help you 85 to 90%. So I am requesting every student pay attention towards every single point that we will discuss. Okay. Now you can ask me, sir, what is the function of a polymerase enzyme? I can tell to all of you friends, every single polymerase enzyme will generally show three common functions. What are two common function? What is that? Polymerization. What do you mean by the word polymerization? Synthesizing the daughter strand. And we all know, right? It is going to synthesize the daughter strand in which direction? 5' to 3' direction. Then the second point, proofreading. And friends, kindly don't confuse. Proofreading is same. Exonuclease's activity is also same, where it will happen in the 3' to 5' direction. These two are the most common functions of every single DNA polymerase. Good evening all, please continue. Now listen to me carefully. Let's talk about the polymerase 1, polymerase 2, polymerase 3. So let's take the first function. What is the first function we will take? First, let's talk about the subunits. My friends, when you talk about the subunits, the polymerase 1 hardly having 2 subunits. That's all. Polymerase 2 having more than 4 subunits. If you look into the polymerase 10, my friends, it is having more than 10 subunits. Please pay attention whatever the points that I am talking. Now friends, second one, if you talk about the polymerization rate, if you talk about the polymerization direction or a rate, what is the common point you can understand? Polymerase 1 also can synthesize 5' to 3', no doubt about it. Polymerase 2 also can synthesize 5' to 3', no doubt about it. Polymerase 3 also can synthesize 5' to 3', there is no doubt about it. Next and unique point, proofreading. Friends, everyone please pay attention. Let's talk about the proofreading. If you talk about the proofreading, my friends, polymerase 1 will do the proofreading in 3' to 5', no doubt about it. And polymerase 2 also will do the proofreading 3' to 5', no doubt about it. Polymerase 3 also will do the proofreading 3' to 5', there is no doubt about it. But my friends, what is the unique characteristic of this particular polymerase 1? Friends, polymerase 1 can also do the proofreading in 5' to 3' direction also. What direction? 5' to 3' direction also. Another very important statement every student has to remember, polymerase 2 cannot perform proofreading in 5' to 3'. Polymerase 3 cannot perform proofreading in 5' to 3'. So what's the unique statement present here? The only polymer, listen the question, you can get a direct question in the part B also. The only polymerase enzyme which do the proofreading in both direction, that is the 3' to 5', 5' to 3'. The only enzyme is polymerase 1. Pol 2, Pol 3 only do in the 3' to 5'. They never do in the 5' to 3'. Please keep that point in your mind. Now the last and most important point, why we are continuously calling polymerase 1, polymerase 3 only the most important enzyme. I was repeatedly saying that the polymerase 3 is the most important. What is the reason? Just because of what I said, friends, high processivity. Let me tell you the processivity in terms of nucleotides. Polymerase 1, it will hardly add 100 to 200 nucleotide. That's all. Once it add the 100 to 200 nucleotide continuously, friends, it will fall down. Immediately it will fall down. But friends, if you look into the polymerase 2, it can add up to 2000 nucleotides continuously. After 2000 nucleotides only, friends, it will fall down. But my friends, when you look into the polymerase 3, what is the statement you have to remember? Polymerase 3 can add more than 5 lakhs. Friends, always remember, I am not talking about the 50,000. Polymerase 3 can add up to 5 lakhs of nucleotides continuously before it's falling down or before its dissociation. That's why, friends, we will be calling it as DNA polymerase 3 is the most important enzyme among all. The only reason is what? Because of its highest processivity. I'm requesting everyone, please pay attention towards every single word that I'll speak, because every single word we have to connect to the upcoming slide. Then the concept become very easy. Why we are calling polymerase 3 is the most important one, friends? Just because of its highest processivity. Do not forget that point. Now, friends, let's talk about every single DNA polymerase in a elaborative way. So let's talk about the first type of the DNA polymerase, friends, DNA polymerase 1. First, we will understand few important things, then we will read about this. The first one, all the scientists thought that, listen to me, all the scientists thought that there is only one DNA polymerase 1 is present, because this is the first polymerase actually identified. It was discovered by a genius molecular biologist named as Arthur Kornberg, and it was the first identified DNA polymerase. All the scientists thought that, of course, there is only one DNA polymerase 1 is enzyme is present. But friends, later when the scientists started doing the experiments with mutated E. coli, with what, my friends? When they started doing the experiments with the mutated E. coli, they found there is a polymerase 2, polymerase 3, polymerase 5. My friends, recently polymerase 6 also discovered. But I want you all people has to listen my statements carefully. How many number of polymerases may be, the common point is that polymerase 3 is the most important one. There is no doubt about that. Which one? Polymerase 3. Now I'll quickly summarize first the overall functions of polymerase 1. Polymerase 1 will do the 5' to 3' polymerization, no doubt about it, like every other polymerase. Polymerase 2 will do the 3' to 5' proofreading, like all other polymerases. And what is the unique function performed by the polymerase 1? That is the proofreading in the 5' to 3'. This is the unique function. Good evening all. Next, and a very important one, you people has to remember, my friends, most important one, DNA polymerase 1 is the major enzyme involved in the DNA repair mechanism. This is really important function. I want every one of you to remember this. Another specialized function I would like to highlight about this particular DNA repair mechanism is that, about DNA polymerase 1. This is the one which will be involved in removing the primer. primer can be removed by the DNA polymerase 1. Do not forget that. Okay, it is the one which removed the primer. Now after removing the primer, who is replacing the nucleotide? My friends, undoubtedly the DNA polymerase 1 only replacing the nucleotides also. Do not forget. So I'm quickly summarizing, all of you listen. DNA polymerase 1 will do the polymerization or synthesis of a daughter strand in 5' to 3'. First function. It will do the proofreading in 3' to 5' also, 5' to 3' also. Fourth function, it is the major polymerase enzyme which is involved in the repair mechanism. Fifth function, it is the only enzyme involved in removing the primer, and followed by the replacing the nucleotides. This is the simplified functions of the polymerase 1. Now listen to me. I am talking about polymerase 1 only, friends. Just listen. This is the structure of a polymerase 1. Imagine. This is the structure of a polymerase 1. Right now we have understood, right? It is having one extra quality. What is that extra quality? It is going to involved in the 5' to 3' proofreading activity. This is what we studied. There is a scientist named as Hans Kleno. What he has done, he wants to understand why the DNA polymerase 1 only doing this particular kind of a function. Why not the polymerase 2 and 3 are not showing this particular function? He got that doubt. So in order to prove, my friends, you know what he has done? He just cut. First, he has taken two chemicals. He has taken trypsin. Sometimes instead of using the trypsin, even he has used another chemical called as, my friends, sabitilicin. So by using the trypsin or the chemical sabitilicin, all of you listen, my friends, he cut this particular DNA polymerase 1 enzyme into two segments. One is called as a small segment, one we called as small segment, another one we called as a large segment. My friends, now he understands everything very clearly. What is that? The DNA polymerase 1 enzyme is performing an extra function, right? What is that extra function? 5' to 3' proofreading. Friends, that particular 5' to 3' proofreading can be exclusively mediated by this particular small segment only. Small segment is the one which is involved in the proofreading in 5' to 3', which cannot be possessed. Which cannot be possessed, right, by the other. Next one, you people has to understand one more important point. If you look into the large one, large segments, what is the point you have to understand? This is the one which is involved in the 5' to 3', 5' to 3' polymerization. And next one, friends, it is the one which is involved in the 3' to 5' exonuclease activity. So friends, this is about the DNA polymerase 1 function. Simple function possessed by the DNA polymerase 1. Okay, everyone is clear till the DNA polymerase 1? Please say yes or no. I did not understand what do you mean by the words camouflaged. Can you tell me correctly? What do you mean by that? Okay, is that clear everyone? Just say yes or no about the DNA polymerase 1. Okay, now friends, let's talk about the DNA polymerase 2. Okay, you can ask me doubts about the DNA polymerase 1. Everyone. Perfect. So now let's talk about the DNA polymerase 2. So friends, I want all the students has to remember about the DNA polymerase 2. It is the enzyme which is actually involved. When it is involved, when the polymerase 1 and polymerase 3 when polymerase okay, Sumaya, I don't use. I mean to say, Reens, you are saying that you are unable to understand whatever I am writing and whatever I am speaking, right? Okay, you are unable to understand the colors. Quickly tell me, by that I'll change. You're getting confused with the colors. Okay, that's okay. Anyway, from tomorrow onwards, I will be using the board itself. There you won't find any kind of a confusion at all. Don't worry with the colors. Okay, now polymerase, I understand. Polymerase 1 and polymerase 3, when these two are non-functional, then only friends, the polymerase 2 will comes into the picture. Now, let me tell you friends, what are the most common clinofragment, which is the large fragment. Priya, large fragment only we will be calling it as a clinofragment. I told you, right, what is the large fragment is doing? It is doing 5' to 3' polymerization, 3' to 5' proofreading activity. This is the one which we will be calling it as the large fragment. Clino is the scientist, Tarun, correct. Sure, Reens, you won't find that kind of confusion from now onwards. I'll use a two colors only. Kindly don't worry about that. And from tomorrow, I'll teach on the board. You people never get any kind of a confusion with the camouflage. Okay, don't worry. Polymerase 1 and polymerase 3, when these two are not functional, then only friends, DNA polymerase 2 will be functional. And once again, every one of you listen my statements, friends. What is the common functions performed by the polymerase 2 enzyme? Listen, polymerase 2 also, friends, involved in the 5' to 3' proofreading. I'm so sorry. One second. Not proofreading. 5' to 3' polymerization like all other enzymes. 5' to 3' polymerization, and in what kind of direction it is involved in the proofreading? It is involved in the proofreading, that is 3' to 5'. And friends, if they have asked you a question in the exam, does the DNA polymerase 2 involved in the DNA repair mechanism or not? Then I want all the student has to remember only one word, that is friends, DNA polymerase enzyme 2 having a minimal role. DNA polymerase 2 having only minimal role in this particular DNA repair mechanism. And another very important point, what I want you people to remember, friends, the DNA polymerase 2 enzyme having a low processivity. Having what, friends? It is having the low processivity. Because of the low processivity only, you never say DNA polymerase 2 is the major and the principal enzyme. Please kindly don't forget the statements at all. So I'll quickly summarize, friends. Whomever getting confused, please try to understand. Okay, DNA polymerase 2 is the enzyme which is only involved when the polymerase 1 and polymerase 3 enzymes are completely non-functional. Like other polymerases also, DNA polymerase 2 involved in the 5' to 3' polymerization, that is involved in the synthesis of daughter strand, and it is also involved in 3' to 5' proofreading, which we can call it as exonuclease activity. At the same time, friends, DNA polymerase 2 enzyme involved in the DNA repair mechanism, friends, but the role is extremely minimal role or a very low. Because of its low processivity, it is not completely involved. But what is the point you have to understand? When these two are not there in the picture, then obviously polymerase 2 only comes into the picture. Now, friends, when compared to the DNA polymerase 1 and DNA polymerase 2, the most important enzyme is the DNA polymerase 3. I am just saying to all of you and reminding you, DNA polymerase 3 is said to be the most important and principal enzyme. exclusively because of its highest processivity. Now I will be explaining step by step, line by line, point by point. Everyone just pay attention. Now one more important point you have to remember. You can ask me, sir, why you are calling only DNA polymerase 3 having the highest processivity? Why Pol 1 and Pol 2 do not have the highest processivity? Can you give me any specific reason? Of course I can give you one important specific reason. That is, DNA polymerase 3 will be always associated with what, friends? Will be always associated with the beta clamp. Every student remember, and which is directly asked part B question. What is the name of the protein that is involved in increasing the processivity of the DNA polymerase 3 in case of a prokaryotes? That is the beta clamp. And friends, please kindly don't think that the same beta clamp is present in the eukaryotes also. Eukaryotes is entirely different because we are a complex organism. That maybe mechanism may be similar, but the proteins involved is almost 90% will be entirely different when compared to the prokaryotic organism. I will be explaining step by step. Listen to me. DNA polymerase 3, as I told you in the starting, it contains more than 10 subunits. First 2 points every student has to remember. Same way, DNA polymerase functions is what? 5' to 3' polymerization very effectively with a high processivity. Then proofreading in the 3' to 5' direction. These two things you all people know. And what you people don't know, now you have to understand. Listen to me. How many subunits I have told to you? 10 subunits. What are those particular 10 subunits? All of you listen, friends. Listen to me. Those units can be divided into 3 areas. One we called core area. Another one we call it as gamma complex. You will understand, friends, easily. Next one we can call it as beta clamp. Okay. So to make you understand, I will be writing one by one. Listen. What core enzyme exactly made up of? Friends, the core enzyme exclusively made up of alpha, epsilon, theta. These 3 together we will be calling it as the core enzymes. Do not forget this point, friends. Next, all of you look into the diagram very carefully, friends. There is a tau dimer is located here. Tau dimer is the one which will connect this particular core enzyme to which complex? All of you pay attention, friends. It is connecting to the gamma complex. Friends, what does the gamma complex contain? Gamma complex contain delta. Gamma complex contain delta prime. Gamma complex contain chi. Gamma complex contain psi. What does the gamma complex contain? Gamma complex contain gamma, delta, delta prime, chi, psi. My friends, all these are getting connected to the beta clamp. All are getting connected to what, my friends? All are getting connected to the beta clamp. So I will be explaining one by one. Once again, listen to me. So, sir, what are core enzyme consist of? Core enzyme is exclusively made up of alpha, epsilon, theta. Now you can ask me, sir, what are the major functions of alpha, epsilon, theta? Every student pay attention and kindly don't forget. Alpha is the one which will be involved in the 5' to 3' polymerization. Epsilon is the one which is involved in the 3' to 5' proofreading. Now you can ask me, sir, what is the major function performed by the theta? I can tell you one thing. Theta do not have any function actually. Now why the theta is required? Theta will always stimulate. What the theta is always stimulating? Theta will always stimulate the function of epsilon. What, my friends? Theta will always stimulate the function of epsilon. Theta do not have any role. Alpha will be involved in 5' to 3' polymerization. Epsilon will be involved in 3' to 5'. Now, here comes a very interesting and I can say important. What is that interesting and important? Listen, this particular core enzyme, how many core enzymes are there? Two core enzymes are there. Most of the students will think that there are two DNA 3 polymerase enzymes are there. One DNA polymerase 3 enzyme will hold one parent strand and one leading strand. Another DNA polymerase 3 enzyme will hold one leading strand, one parent strand and another lagging strand. That is wrong statement. There is only one DNA polymerase 3 enzyme is present, my friends. It is the one which basically hold leading strand also, lagging strand also. How? Because it is having two units. That's why we can call it dimer. This is one monomer. This is the another monomer. Everyone pay attention. Now these two monomeric units connected to the gamma complex. I want every student has to listen. If you remember these terms in the process, it is dead easy. The gamma complex, my friends, we will be actually calling it as a clamp loader. What do you call it as? Clamp loader, which can load the beta clamp on the core enzyme of the DNA polymerase. You can see in the animation also very effectively. Now, what is the function of a tau dimer? Tau dimer connect the core enzyme to the gamma complex. What is gamma complex called as? Clamp loader. What is the function of a clamp loader? Clamp loader is the one which can load beta clamp to the core enzyme. What is that clamp loader or gamma complex consist of? Delta, delta prime, chi, psi. And last and final one, what is that? Beta clamp. What is that one, friends? Beta clamp. Beta clamp is the one which is exclusively responsible for increasing the processivity of the DNA polymerase 3 enzyme. Now you can ask me clearly, sir, how does this beta clamp will go and associated with the core enzyme? Of course, that is exclusively because of the clamp loader only. Now let me tell you all the subunits with the different names. Listen to me. All the subunits with the different names. So when only core enzyme is present, when only core enzyme is present, everyone listen, friends. Only core enzyme, alpha, epsilon, theta. Listen, my friends. So now core enzyme plus which is associated, tau dimer is associated. Now you know what do you call, my friends? You can call polymerase 3 prime. What do you call, friends? Polymerase 3 prime. Now next one, when a core enzyme plus tau dimer plus gamma complex, then you know what do you call, friends? Polymerase 3 star. Polymerase 3 star. Then when you call complete polymerase enzyme, or when you can call polymerase holo enzyme, when you can call holo enzyme, when there is a core polymerase, when there is a core enzyme, tau dimer, gamma complex plus beta clamp, when all together, then you can call, friends, DNA polymerase 3 holo enzyme. What do you mean by the word holo enzyme, friends? Holo means a complete enzyme. Very simple point. What do you call DNA polymerase 3? Holo means complete enzyme. Very, very simple point. Okay. So right now, friends, right now what we have actually discussed. Right now we discussed actually the DNA polymerases present only in the prokaryotic organism. But if you look into this particular slide, I have told to all of you very clearly, in case of a eukaryotic organism, friends, we read that there are 5 DNA polymerases are present. So friends, let me explain you every single polymerase enzyme involved in the eukaryotes in a simple and elaborative way. Okay, I will explain one by one enzyme briefly, friends. Please let me know if you find any kind of a doubt. So let's start with the first DNA polymerase enzyme in case of eukaryotes. Polymerase alpha. I will be explaining one by one. Just listen to me peacefully. Polymerase alpha is the enzyme which is always initiated with association. Which is always initiated with association. Or otherwise you people can remember like this. DNA polymerase alpha is the enzyme which is associated with the process of initiation. Just directly remember, which will start the process of initiation is the polymerase alpha. Now here comes an interesting point. What is that? If you quickly recall, DNA polymerase 3 enzyme, if it want to synthesize the new strand of a DNA, compulsory what do we require? Compulsory we require the primer. But you know the interesting point, friends, here DNA polymerase alpha itself having intrinsic primase activity. What, friends? DNA polymerase alpha is the one which is having the primase activity, which means it is the one which is involved in the synthesis of primer. Now second point, my friends, this is the interesting point. All of you pay attention. This is the one parent strand, this is the another parent strand. Now all of you look into this. There is a addition of one primer in the leading strand, there is a addition of one primer in the lagging strand. Here comes interesting point. I have repeatedly said it to every one of you, polymerase alpha is not the important enzyme, and I said it to all of you, polymerase delta is the most important enzyme. But what is the interesting point that I want to convey here to all of you? DNA polymerase alpha is the enzyme which is involved in the addition of the primer. Friends, after adding the primer, it will only start elongate the DNA. It will only start elongating the DNA. Now you can ask me, sir, then why you are saying polymerase delta is most important? The reason, friends, polymerase alpha cannot increase the new strand or cannot synthesize the daughter strand continuously. Then what it will do? Friends, polymerase alpha can add only 20 to 50 nucleotides only. That's all. It is just will add 20 to 50 nucleotides. Then immediately what is happening? Immediately, friends, the polymerase alpha can be replaced by the delta. Now you can ask me a question, sir, you said that polymerase alpha is involved in synthesis of primer, polymerase alpha only continuously adding the nucleotide 20 to 50, then why it is falling down? Why alpha is replacing delta? Everything is fine, then why we have to replace? The important answer for that is polymerase alpha having a low processivity. You only tell me, friends, without processivity, how the polymerase alpha can synthesize a long strand of DNA? We have to synthesize a huge strand of DNA at a limited amount of time, most importantly with great accuracy. Yes or no? So friends, we have to synthesize it accurately. If the enzyme having low processivity, it cannot do that. That's why, friends, polymerase alpha immediately replaced by the delta. One more point I can highlight here. What is that? DNA polymerase alpha do not have proofreading activity. It is not involved in the synthesis of, it is not involved in the exonuclease or proofreading or checking the errors. These are all the major reasons we can say that the polymerase alpha is not the major enzyme. I am quickly summarizing, friends. DNA polymerase alpha is the enzyme which is involved in starting of the initiation. Why? Because the DNA polymerase alpha having the primase activity, so it synthesizes the primer which is having 11 plus or minus 1 nucleotide. Once it add the primer, polymerase alpha only starts synthesizing the nucleotides continuously. Then immediately what is happening, friends? After 50 nucleotides, it immediately fall down. Polymerase alpha can be replaced by the delta. The reason behind that, my friends, it is having extremely low processivity. Most importantly, friends, it do not have the proofreading activity also. Do not forget the statements. Everything there in the PPT, you no need to worry. Now, Next enzyme, polymerase beta. So I am giving you one important indication. Listen my statement. In the prokaryotic organism, what we read, friends, DNA polymerase 1 is the major enzyme involved in the DNA repair mechanism. That is what we studied. My friends, all of you listen. DNA polymerase beta is the major principal enzyme involved in the DNA repair mechanism. I can tell you very clearly, DNA polymerase beta is the major enzyme involved in the DNA repair mechanism. Here comes a very interesting point. What is that? DNA polymerase beta is the enzyme never ever involved in the polymerization. No role in synthesis. No role in synthesis means what? Synthesis of a daughter strand. It is not at all involved in the synthesis of a daughter strand. Obviously, my friends, it do not have the proofreading activity also. What is the point I want you people to remember? In case of a prokaryotes, polymerase 1 is the major enzyme involved in the DNA repair mechanism. In case of a eukaryotes, polymerase beta is the major enzyme which is involved in the DNA repair mechanism. Please kindly do not forget the statement. Now we are talking about the unique enzyme, the most important enzyme, king of all. In case of a eukaryotes, polymerase delta. Why? You can ask me. Let me tell you the reasons. First reason why I am calling DNA polymerase delta is the most important enzyme. The first reason is the high processivity. High processivity. The second reason, it will be involved in the proofreading activity. Friends, now here comes the question which was asked more than twice for the part B. Direct question. Okay. So more than twice the question was asked. What is that? How does the DNA polymerase delta having the highest processivity? Just now we read, in case of a prokaryotic organism, how does the DNA polymerase 3 enzyme having the highest processivity? Just because of the beta clamp. Just because of beta clamp. Now you only tell me, is there any beta clamp is present in the eukaryotic organism? Not at all. We do not have any beta clamp. Now someone has to replace the function of a beta clamp in the eukaryotes. What is that? We will be calling it as the pCNA. What is that, friends? pCNA. You no need to remember the full form. I am just writing. We can call it as a proliferating cell nuclear antigen. What do you call, my friends? Proliferating cell nuclear antigen. This is the name of a protein which is always associated with the polymerase delta. As a result, it increases the processivity. Then polymerase delta will continuously start adding the nucleotides without falling down with high precision and accuracy. Do not forget that. And what is the another unique function that I can highlight? That is, DNA polymerase delta do not have any role in the DNA repair. No role in the DNA repair. Now tell me, let me tell you one of the common point once again. Listen to me carefully. I said to all of you, in case of a prokaryotic organism, DNA polymerase 3 is the major enzyme. I have also highlighted DNA polymerase 3 is only involved in the polymerization and proofreading, but DNA polymerase 3 do not have any role in the DNA repair mechanism. Pol 3 never involved. Same way with the polymerase delta also. This is the major enzyme involved in the eukaryotic organism for the process of the proofreading, also for the process of polymerization also. But my friends, polymerase delta also do not have any kind of a role in this particular repair mechanism. Please kindly do not forget the statement. Okay. Friends, is that clear everyone till here? Everyone please say yes or no. Everyone, friends, everyone. Okay, Reens, now I hope you are not getting confused with the words and colors. Is that clear, everyone? Let me know, friends. I hope it's clear to all of you. And friends, listen to me. From tomorrow we will be having what? Photosynthesis part 3. We are having photosynthesis part 3. Tomorrow it will be finished. So I am telling to all of you friends, from Monday onwards. So from Monday onwards, we will be having classes morning also. Okay. So that is 5:45 a.m. to 6:45 a.m. every single day. Okay, till Monday to Saturday. Okay, you no need to worry about that. Please join the Telegram. In the Telegram I will send you the message by 5 a.m. itself. By that you can prepare 45 minutes before itself. Okay, okay, the next one, 8:30 a.m. to sorry friends, 8:30 p.m. to 9:30 p.m. Okay, so what I am going to do is, from Monday morning I will take molecular biology, evening I will take the plant physiology. Okay, I have kept a target of May 30th. I have kept a target of May 30th. I will finish minimum 10 lessons, minimum 10 lessons I'll keep in front of you, undoubtedly, with the question solving. Okay, and my sincere request to every one of you friends, attend every day 5:45 a.m. and 8:30 p.m. It's my responsibility to give the message by 5 a.m. in the Telegram, and let's start the class very sharp 5:45 a.m. The reason keeping the class early in the morning is you can wake up. It will become a very good habit to all of you till the end of the exam. Okay, so please make this particular habit, friends. Okay, I will see you tomorrow same time 8:30 p.m. in the photosynthesis part 3. Okay, and from Monday 5:45 a.m. 8:30 p.m. Okay. Okay, thank you, Rins. Thank you. Okay, please be attend regularly, friends. Okay, that's all for now. I'll meet you tomorrow sharp 8:30 p.m. We are going to finish the photosynthesis completely. That's all, friends. Good night to all of you. Good night. Thank you so much. Good night. Please attend regularly. Thank you.